Alright guys, welcome to our channel. So this time we're going to talk about voltage divider theorem under DC circuits. So voltage divider theorem is useful when we try to find a voltage drop across each of the resistor. However, it is only applicable in series circuits. So what is the reason why it is only applicable in series circuits? So let's say that we have a resistors that is connected in series. This is series. And then we have a voltage source. Of course, this is positive and negative, so therefore the current will flow through here, IT. So in series circuits, IT is just equals to I1 and I2. What about the voltage drop across each of the resistor? We have here, let's call this R1, this is R1, they call this R2. Therefore, this is V1 and V2. So we can use voltage divider theorem in order to find the values of V1 and V2 right here. So how about we have a resistor connected in parallel. Let's say that this is the voltage source. It's connected that one. This is parallel. So in parallel circuits, VT is just equals to V1 and V2. Because whatever magnitude that is our voltage right there is just equal to the voltage drop across this of the resistor R1 and R2. The only thing that is different is that the current in parallel is not constant. Therefore, we can only use the current divider theorem in parallel circuits. But in this video, let's just focus on voltage divider theorem, which is going to focus also in series circuits. So that's it. And right now we are going to how do we able to use voltage divider theorem in series circuits. So let's say that we have a voltage source, DC source right here, and then we have a couple of resistors connected in series. Of course, this is from positive to negative, so that the current will flow through here. Whatever values of IT is just equals to I1 and I2, and this is positive and negative. This would be right here a voltage drop across R1, and then positive and negative voltage drop across R2. So how do we find the V1? So using the voltage divider theorem, V1 is just equals to the voltage source, the VT, multiplied by that resistor R1, and then divided by the total resistor or the total resistance. The same also with V2. We can use VT multiplied by, of course, R2, and then divided by RT. So we can also have V3 is equals to VT multiplied by R3 over RT if there are another resistor connected in series right here. So this would be the voltage divider theorem that we are going to have. So in order to understand the topic, let's go for some of the examples. So what we have here, example number 1, we have a DC voltage source which has a value of 220 volts, and then we have a 2 resistor connected in series. The question is find the voltage drop across each of the resistors. So therefore we are going to find the V1 right here and then the V2. So using voltage divider theorem is just so easy. Let's put solution. So V1 is just equals to VT multiplied by R1 and RT. So our RT, since this is series, just equals to R1 plus R2. So this is equals to R1 is 50 ohms. We have here 50 ohms, and then R2 plus 100 ohms. R2 is 100 ohms. So therefore, RT is equal to 150 ohms. So let's go calculating the V1. VT, our VT is this one, the voltage source, that is 220 volts. Multiplied by, of course, R1. Our R1 is 50, and then divided by our RT is 150 ohms. So we can cancel now ohms and then putting that all in the calculator. Therefore V1 is equal to, that is 73.33 volts. So we have now V1, which is the voltage drop across R1. How about the voltage drop across R2 or V2? So the same also with V1, that is VT multiplied by, right now we're going to use R2 and then divided by RT. Since the resistance 2 is where the voltage drop of the resistance 2 happens or occurs. So let's go finding that 220 volts R2 is 100 ohms, and then RT is 150 ohms. So we can cancel ohms. Therefore, let's put that right here. Our V2 is just equal to, that is 146. That is 146.67 volts. So we have now V1 and V2. So we can check if these two are correct. So in series circuits, we all knew that the voltage source is just equals to V1 plus V2. And then our voltage source is 220 volts. That is equals to V1 is 73.33. And then plus our V2 is 146.67 volts. So let's check if these two are equal. So that is 220 volts. So therefore, V1 is correct and then V2 is correct. So that's it for example number 1. Let's go to example number 2. So example number 2, we have to find the voltage drop across R1. So it only needs to find V1. So we have here a 220 volts again. This is DC voltage source. And then we have 3 resistors connected in series. So let's go finding that V1. So let's find solution. This is solution. V1. So how do we need to find V1, or how do we find V1? So V1 is just equals to VT and then R1 and then RT. Since we have 3 resistors connected in series, RT is equals to R1 plus R2 plus R3. So we have R1 is 100 ohms, we have R2 is 130 ohms, and we have R3 which is 70 ohms. Therefore, we are going to have RT is equal to, that is 300 ohms. So we have now RT, we can now find V1. So V1, we have VT which is 220 volts again, and then R1 which is 100 ohms, and then RT rather, that is 300 ohms. So we can cancel ohms, leaving behind V1 is equal to, that is 73.33. Sorry, that is 33 volts. So we have now the voltage drop across R1. So basically we can check if this is correct. So however, we need to find of course the voltage drop across R2 and R3. So how about we need to find, let's say we need to find V2 right here. So V2 is just equals to VT divided by, multiplied by R2 times RT. So VT is equals to 220 volts, and then R2 is equals to 130 ohms divided by RT is equals to 300 ohms. So what is V2? V2 is just equal to, that is 95.33 volts. So we have V2. How about V3, guys? So V3 is equals to VT. Let's just substitute that directly. That is 220 volts times R3 is 70 ohms divided by 300 ohms. So that is going to V3 is equal to, that is 51.33 volts. So this is going to be our V3. So let's check if we have a correct answer for V1. That is VT is equals to V1 plus V2 is equals to, plus, that is plus V3. So our VT is 220 volts. Our V1 is 73.33 volts. And then we have plus our V2 is 95.33 volts. And then plus our V3 is 51.33 volts. So let's just calculate if these are correct. Therefore, that is 219.99 volts, which is approximately equal to 220. Therefore, we can conclude that our V1 right here is correct. So that's it, guys. Thank you for watching. I hope you learned something from this video and study well. And if you have some question, you can comment down below and I will try to find the answer that right away. So that's it, and thank you so much.